So for this talk, I actually want to tie together two things. So yes, I'm going to be talking about a technology, and those that you know me well, I will always enjoyably talk about various technologies and C++ code that we're writing. But I also want to have a second message here where I want to emphasize that it's not just the technologies that move us forward as a community, but also, particularly for this part of Condor, the trust relationships. So I want everybody to think a little bit as they can about trust relationships and how these enable different aspects of our activities. As I was preparing this talk, I made a mistake of going through old slides, and I actually realized this is now becoming a bit of a serial discussion. So especially as we've been doing the ID tokens work within Condor, and particularly in the last 2 or 3 years, we've really been making progress in how we view trust relationships, how we do security architecture in Condor. And you know, I realize this is now the third year in a row that we've been really trying to push on this theme of thinking about how trust relationships and how security works in your Condor flow. So what I'm not going to talk about today too much is how ID tokens works. There was a wonderful talk from Todd yesterday that hopefully none of you missed, and shoot, all my slides I think did it just as fine in 2021. But I want to talk today at least a little bit about what problems we have remaining. And to get there, we have to think about how trust relationships work within Condor. So because all the CHTC staff members made the mistake of posting their happy headshots on the web pages, I've conscripted a couple of them to come be the owners and operators of various daemons. So we have Emil, who's going to be running our pool for us today. Aaron Moat is happily running the execution points, which we will sometimes refer to as starties. And Rachel is our person with the crown on for access point. So to understand where we're going, you have to at least understand a little bit of the history here. And when Condor started, and we're on 38 years, and now it does seem like it started to be a long time ago. 37 years. Each individual entity within a Condor system tended to have its own owner. So it's not only we didn't have one Aaron Moat running all the execution points, but really when it was desktop scavenging, every desktop had an owner. And the vision was every desktop owner had some idea of what you were going to do with their desktop. And they had to be involved in some aspect of the decision-making process. So, you know, Christina might decide that her execution point only provided services to chemists on Wednesdays. Brian Lynn might decide the physical sciences are for the birds. So he's only going to work with the humanities on Thursdays. And because each of these entities had strong ownership, there really evolved a strongly identity-based authorization model. So each owner had to become apparent to the others, and demons that needed to work with each other had to have some sort of mutual trust relationship. And this reflected the trust model and how things worked, but it ended up with a somewhat complex system. So here we have a diagram of somebody who spent the weekend reading the Condor manual, the security session. And I tried to look down and see exactly what does it take to set up something like SSL, which has all these different aspects. Each daemon can have its own identity, and you can bootstrap trust by having a central third party who distributes trust relationships. You can set the wonderfully named knobs auth_SSL_server_CA file. And because you might trust different people for clients, we even made 2 knobs for configuring CAs. And in fact, because sometimes one file is not enough, we actually made 4 knobs so you can actually have directories of CAs as well. Long story short, if you write down all the steps to set up that full set of trust relationships and then decide on how the global identities map to local identities, and then you take those local identities and write down the authorizations, yeah, you end up looking like this guy. And this is reflective of maybe how we want it to work when there's lots of owners in the system, but not particularly simple. So really the first crack in the trust framework, the thing that started admitting that this is not exactly how all the Condor systems work, came in 2009. When, again, we pride ourselves in having short, memorable configuration knob names. We had the wonderful sec enable match password authentication, which nobody knows how to spell, or nobody knows exactly what it does. But what this allows is the execution point. Instead of having an identity in the system for whoever it might claim as it, just generates a random string, sends that random string up to the collector, and says, you know what, collector, whoever you think is good enough to run on this execution point, you just give them this capability, you give them the random string, and I'm going to give them services. I'm going to allow them to claim me and run jobs. So all of a sudden, once this hit about a little over a decade ago, the start D no longer needs to authenticate with the submit host. It no longer needs to be that strong, who are you? Who are you, my domain? What do I have configured in terms of permissions for you? And the execution point starts delegating all that decision making out to the central manager. It says, you know what? I'm part of this pool. Whoever's good enough for the guy running the pool is good enough for me. And this reflected the fact that while you still can use Condor as a desktop scavenger, there's this strong component and dominant component now of using these and something that might look like a traditional batch cluster. So you don't have all these unique individuals out running your execution points. Instead, most likely you have some person that's running your pool. So it's not Brian and Christina and Moat. It actually is just Emil who is running the whole show. And the fact that Emil's execution points is able to trust Emil's central manager to make decisions starts to feel pretty natural. And in fact, so here you see the evolution in trust. The fact that there's one person running the cluster starts to be reflected in the technologies and capabilities that get offered. So, in 2019, we introduced ID tokens. And this allowed us to, yet again, start to move forward and simplify how we offer trust and bootstrap trust in the Condor cluster or Condor system. ID tokens provide a couple unique things. One, there's a namespace for the identity. There's the idea of a trust domain that everybody within this domain is run by the same set of administrators. Another thing that's unique to ID tokens among all the systems is Condor itself can create the credentials. You don't have to go to a third party, set up SSL, set up GSI. You don't need your existing Kerberos or your AD controllers to manage the authentication. You can just use Condor and have it start to create credentials for you. And in fact, you can even bootstrap. So you can have Condor say, this anonymous person came up claiming he's Brian. Go call the admin and see if this really is Brian. If so, I can approve and create this credential. But what we really didn't start talking about in the ID tokens tutorial yesterday is where does this fall flat in our face? What are the limitations? So one big limitation for ID tokens, it was a conscious choice to make it simpler, but definitely some clusters notice this acutely, is we have a symmetric key for the signature. That means in order to verify a token is authentic and wasn't forged, you need the signing key that is used to create tokens. So the analogy here is if the only person who can actually look at your driver's license was the DMV, right? All of a sudden, you can't send the DMV to every liquor store in town trying to kick out 18-year-old kids. You need, in some cases, a distributed system. You need to separate the roles of creating the credential from being able to tell whether or not the credential is fake. So that's one really acute part of ID tokens, and you saw Todd's solution and what we do today in Get HTCondor, we just say, shoot, give the signing key to every single host you have, which particularly in some places where people might not trust the host, or the host is in the cloud, or the host is halfway across the country, it's hard to start deciding to send out your signing key everywhere. And then also, ID tokens has this wonderful ability to bootstrap and give things to anonymous users. But we don't actually give you a good mechanism for bootstrapping itself. That we end up actually telling you, go use some other protocol to bootstrap. So the first fix in ID tokens is actually something that we've worked on for Condor 990. Jamie Frey took it home. And this is actually, instead of actually fixing ID tokens, slightly changing the model. That we now, at execution points, send capabilities up to the central manager. And anybody with the central manager who decides is an okay individual to run the cluster, the central manager will give that capability up to that person. Here, we decided Moat is trustworthy not only as a timekeeper for the session, but with the capability, the admin capabilities for our cluster. And then that individual can then go take that capability, hand it at the execution point to do things like shut it down, change configs, fetch the logs, things like this. And all of a sudden now, instead of trying to fix the authentication, we're changing the trust model again. We said, we are willing to give out capabilities to admins and have the execution point delegate out to the central manager decisions on who's good enough to be my sysadmin. The second part towards fixing ID tokens is again going to the fact that we don't have a way to bootstrap anonymous authentication. And we tell people, go use SSL. But then we pretended that's, I think it was slide 4 or 5, didn't exist. And we pretend that SSL is actually a reasonable thing for most admins to set up. So how do we do things? Do we make it easier to work with CAs, or do we pay DigiCert a lot more money? Instead, we're getting to our TOFU. So here, TOFU, the acronym is Trust on First Use. And instead of relying on how we traditionally think of SSL, where we go to a global purveyor of trust, whose business is being a trustworthy organization, we take inspiration instead from SSH. So yes, when we go to our banking website, we go to those global entities, the CAs, but that's not the only way we establish trust. And most people are comfortable with logging into hosts via SSH. So the idea is, instead of trying to make SSL necessarily easier and easier to bootstrap CAs and get certificates, the idea is we're starting to look and be SSH inspired and say, if that's good enough for you, maybe this is good enough to bootstrap for Condor. So here's the prompt you get when you go to an unknown SSH server the first time. It says, here's a fingerprint I see. Do you want to trust this person? It's going to write it down locally. And every time from then on, it's going to compare that remote host's public key versus what it recorded the first time. So we're going to do the same thing within Condor. The central manager is going to generate a self-signed CA certificate and start generating its own host service. And on the client side, whenever we start seeing host certs we don't recognize, it's going to start asking the user what it should do next. This is something that's still cooking a little bit. I'm hoping it's going to land somewhere around 9.10 with Condor. But the current branch looks like this. So you type Condor Q to a remote service you don't know, and it says, here's what I saw. I don't know what to do with this guy. I don't trust him. Here's a fingerprint. Make your decision. Yes, no. Would you like to trust this now in the future? And just like with an SSH, inside under the hood, it's going to create these known host file and record all the different Condors it saw. Known host file, if you're familiar with SSH, this is going to look pretty familiar. It's line-based. You can comment things out. You can say not to trust people. And the thought is this is going to help us bootstrap that SSL off and then enable us to fix one of the glaring issues with IDTOKENS, which is bootstrapping is not nearly as easy as we'd like to be. So this enables us to have a new trust model, one that mirrors SSH. It is definitely different than your traditional PKI. But the idea is it's something that a lot of us understand how to grasp and think about. It provides us a lot of simplicity with things getting going, whether it's getting ID tokens or just remotely querying services. And for me, I personally hope this is the last or one of the steps to removing really insecure default configurations, such as the existence of claim to be or anonymous authentication. Moral of the story for today, changes in technology and trust models can go hand in hand. The original model we established was fairly complicated, but maybe was how we thought of the systems many, many years ago. And then really over the past 2 or 3 years, we've been hacking at the complexity and trying to make things simpler. And hopefully this is starting to be reflective in the technology. And then this is now the 3rd year we've talked about trust and Condor. And I'd point out that assuming all this comes in Condor 9.10, all of a sudden we now have a public key associated with the trust domain. So that's going to be a fairly impactful concept, and we'll hopefully see everybody in 2023 and talk about what we can do with that. All right, thank you.